In this video, we would like to talk about a term called thermal resistance. First thing that I want to tell you is the phenomena of transmission of the heat through a material where no particle of the medium has a permanent displacement. Each particle vibrates about its mean position, transmits the energy to the other particle is called as conduction. It happens in a solid material. How much of the heat flows in a solid material per second depends on the factors like area of cross section of that solid material. Larger the area, more heat will go. Difference between the temperature of the two ends, more the temperature difference, more heat will go. And inversely proportional to the length of the conductor, bigger the length, less heat will flow because it has to overcome all the opposition to the flow across the length. Each particle has to pass the heat. That's why longer the length, difficult for the heat to go. That proportionality can be eliminated by putting a constant. That constant is called coefficient of thermal conductivity, K, where this K is called coefficient of thermal conductivity. In fact, defining this coefficient of thermal conductivity is quite easy. How can I define that? See, little carefully. Yeah. If a wire is having a length of 1 meter, area of cross section of 1 meter square in SI system, the temperature difference between the two ends is only 1 degree centigrade or 1 Kelvin. Substitute all these values in this equation. What happens then? dq by dt equal to K, area is 1, delta theta is 1, L is also 1. That implies K equal to dq by dt itself. This is the definition of coefficient of thermal conductivity. What I can define? Coefficient of thermal conductivity is rate of flow of heat through a wire of length 1 meter having an area of cross section 1 meter square when the temperature difference across the ends is only 1 degree centigrade or 1 Kelvin. That's how we define coefficient of thermal conductivity. Now let us continue our discussion because our aim is to talk about thermal resistance. So you got a formula dq by dt equal to Ka delta theta by L. If you rearrange these terms only keeping delta theta in the numerator, you can get that Ka into the denominator. So whatever written in the denominator can be called as thermal resistance. So thermal resistance R can be written like L by Ka. This, as the name itself tells you, resistance is a opposition to the flow of heat. What it means? If thermal resistance is more, it is difficult for the heat to flow and vice versa. So, if you notice that thermal resistance little carefully, thermal resistance equal to L by Ka. Of course, K is a proportionality constant. Thermal resistance is directly proportional to length of the wire or rod or a solid material. More the length, more the thermal resistance. Inversely proportional to area of cross section. So in the further videos, we will be talking what happens, what is the effective thermal resistance when the rods are connected in series or else when the rods are connected in parallel. That we will discuss in the next part. Here the important part is to understand that thermal resistance is somebody who is a measure of opposition to the flow of the heat through the rod, through the material, through the solid material. More resistance means less flow of heat, less resistance means more flow of heat. That's a basic understanding I want you to get further, right? Thank you for watching.